We are on block 2 from topic 5 on page 135 in our workbook. In your baskets in the middle of the table, you will find little containers. Do not, I know you're tempted to shake them, but I would ask that you not. Inside those containers are integer pieces. I would like you to, as quietly as possible, dump them onto your desk. Integer pieces have one side that is red, one side that is black. The black side represents a positive 1. The red side represents a negative 1. And we use these in math to help us visualize some math problems. So many of the problems that we work today are very simple. That is not the purpose of this lesson. The purpose of this lesson is for you to visualize these and use these so when you get a harder math problem, you know how to work the problem. So I do not want you moving on or creating patterns and playing with your chips all hour. If you have your chips on your textbook, make sure that they are on your desk because we will be writing on our textbook. So if they are on your book, put them on your desk. One at a time is taking forever. Using your chips, I want you to model with your chips a positive 1 on your desk. Positive 4 on your desk. Show me what a positive 4 would represent. Black stands for positive, red stands for negative. I see most people have something like that out on their desk. They might be arranged different ways, but I see 4 black chips on your desk. Does that represent positive 4? Yeah. I agree it does. So in your book, let's go through and just list 4 positives so that we have a symbol. Some notes. Okay, that's the obvious answer. I want a positive 4 laid out in your chips. That's not an obvious answer. I don't mean rearrange the chips in a different pattern. I mean lay out some chips that still represents a positive 4. Okay, I see an example right here up front. Landon, how many black chips do you have on your table?
6.
He has 6 black chips. I don't know how in the world he's going to feel, 1, 2, 3, 4, 5. He feels like that's going to represent a positive 4. But what else do you have laid out on your table?
2 negative red.
He has 2 negative red chips. How does that essentially make a positive 4?
You would subtract the negative 2 from this positive 2.
Okay, subtracting 2 from the positive. What you got? Got a comment? No, about this problem.
Oh, the 6 positive plus the 2.
Yeah.
Oh, yeah.
So what's happening here is these are essentially creating what's called a 0 pair. 0 pair is nothing, right? So that means these kind of poof and vanish. And what's left is 4 positive. Okay? So that leaves the game wide open as to many different ways for me to create a positive 4, right? So what is another way I could write a positive 4? John, what you got?
4 negative
4 negatives
and 8 positive.
and 8 positives. Is that going to represent a positive 4?
Yes.
So how many 0 pairs do I have?
4.
4 0 pairs. That leaves 4 positives left. So it does represent a positive 4. I kind of imagine these 0 pairs of like a video game of where something hits something and the little cloud smoke and poof, it vanishes. That's what I imagine when it happens. Okay, I could go on with examples of these all day long. I want to look at 2. Now we want to model a negative 4. Well, obviously, there's an obvious answer. That's the obvious answer, right?
Yes.
Okay. Wyatt, what's a non-obvious answer?
4 red ones and 2 black. No, my bad. 6 red ones and 2 black ones.
6 red ones,
6
6 negatives.
and 2 positives.
Okay, that's a lot, so I'm just going to write it. 1, 2, 3, 4, 5, 6, and 2 positives. So I have 2 sets of 0 pairs that vanish, and I'm left with 4 negatives. Sir, what do you have?
I have 10 negatives.
Oh gosh.
10 negatives and 6 positives.
All right, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 negatives. And how many positive?
6.
1, 2, 3, 4, 5, 6. So how many 0 pairs?
6.
6. That leaves me with 4 negatives left. I could go on and on finding negative 4. But we'd be here all day. Okay. So like I said, we're going to use these to help us solve problems. So, again, some of us might see the answer to some of these problems right off the top of just by looking at it. That's not the point. The point is figuring out these integers and how they work. So, I have the problem negative 4 plus 6. What number is starting that problem off? Negative 4. So I'm going to write negative 4 because that's my starting value. And I'm going to write 4 negatives in my working space. That's what's starting this problem off. Okay. Then I see a plus sign.
It's for a positive 6 to be added.
Okay. I see a plus sign, so does that mean I'm going to be adding tiles or taking tiles away? Adding tiles. What color tiles am I adding?
Black.
Black. So positive. How many black positives? 6 black positives. So now I've shown the problem. But I see some things created that I can work with here. What do I see?
You can take away
You can do the
4 of them.
you just
I have some 0 pairs.
yeah, the 0 pair.
So I'm going to circle my 0 pairs, which means they vanish. What am I left with?
Two positives.
2 positives. So my ending value is 2 positives. So let's recap our actions here. We started with 4 negative tiles on my workspace. From there, what did I do? Added what?
4 of the positive 6.
I added 6 positive tiles. When I added 6 positive tiles, I wasn't done. What did I do next?
You added 4 negative.
You
Counted the
see
remainder.
how much the remainder of it was.
What does all these circles represent?
0.
I removed my 0 pairs. How many 0 pairs did I have?
4.
I removed 4 0 pairs. Then I was left with just 2 positives. So that's my answer. So I know -4 plus 6 equals 2. Okay, let's look at another. Number 4. 5 plus a -9. What am I starting with? 5 positive. So I'm going to have 5 positive up there. Then I see a plus sign. Am I adding or taking tiles away? Adding tiles. What kind of tiles do I need to add? Negative ones. How many negative ones? 9 negative tiles. Now what do I see created here? Some 0 pairs. How many 0 pairs? So I'm going to circle my 0 pairs for them to vanish. So what is left? -4. Recapping the actions, I started with 5 black tiles. What did I do from there?
You added -9.
I added 9 negative tiles. Then I wasn't done. Then I did what? Removed 5 0 pairs. So what did 5 plus a -9 equal? -4. Honestly, who knew that before even working the problem and knew it just looking at it? That's fine.
Did you put that negative sign in front of it?
What?
Did you put the negative sign in front of it?
It is in front of them.
No, when you put added on my thing.
I don't know what you're saying.
That, you see where after you said 9?
Oh,
Yeah, can I move that?
added 9 negative tiles.
I couldn't move this negative in front of the 9.
Added -9 tiles. What?
On Agile Mind, do we have to work it like that?
I'm showing you all the different methods. It might give you a problem that's been worked like this already and you have to know what they did. That's why I'm teaching you all the methods. Today I'm teaching you with tiles, tomorrow I'm teaching you with number lines, the next day I'm teaching you with all my tricks.
That's gonna be fun. Sound like your magic.
So, number 5 says -3 plus a -4. What am I starting with? -3. I'm just going to handwrite -3. So I see a plus sign. So am I adding tiles or taking away? Adding tiles. What kind of tiles do I need to add?
Positive. Negative.
Negative. How many negative? 1, 2, 3, 4. Okay, I need to look for my zero pairs. How many zero pairs? No zero pairs. So now what do I do?
You add, you count them.
You count how many negatives and how many do I have?
7.
So my ending value is -7. So recapping the actions I took, started with -3, then what did I do?
Added 4
negative
negative tiles.
4 negative tiles.
And added
Yeah, it's in the plus sign.
That's the plus sign.
It tells me to add tiles. Did I remove any?
No.
So -3 plus a -4 equals what?
-7.
-7. So most of you knew that just looking at it?
Yes.
Impressive.
We gotta do
Number 6. We're kind of recapping integers, adding integers. So look back at problem 3, 4, and 5. What problems gave us a negative answer? 4 and 5. So looking at 4, raise your hand. Why did it give me a negative answer? Yes, sir.
Because we had 5 pairs, and if you subtract those 5 from the 9 without the negative sign equals 4, and
Fine, I just don't know where you're going. Yes, sir? There are more negative tiles than positive tiles. Then, number 5, you said turned to a negative answer. Why did this turn to a negative answer?
Because there was no negative.
Yes, sir.
those numbers were negative, so the negative took over.
Both integers were negative, so the only choice it had was to be a negative answer. So that is the only way for us to get a negative answer. When both integers are negative, when more negative tiles than positive tiles. This is number 6. When both integers are negative, or when there are more negative tiles than positive tiles. So raise your hand. How could I get a positive result? Brady?
Would it be the exact opposite?
Yeah, so give me an answer.
When both integers are not the same and are positive?
When both integers are positive, or, Landon,
When there's more positive tiles than negative tiles.
or when there's more positive tiles than negative tiles. Those are the 2 ways I can get a positive answer. And we didn't get a problem with a 0 answer, but raise your hand if you know how I could get an answer of 0. Yes, ma'am.
When there is an equal amount of negative and positive tiles.
That sounds beautiful. When there's an equal amount of positive and negative tiles. My answer says when integers are opposite. What does opposites mean?
They're the same, but not the.
They're the same, but
They're the
a
opposite,
different
but the same
positive and
A
negative.
different sign. So 5 and -5 are opposites of each other. So I liked how she worded it because you probably would understand that better when you go back to read this. You could put what I put, or you could say when there's the same number of positive and negative tiles. Okay, so we have been looking at adding with integer pieces. Now we're going to look at subtracting with integer pieces. First, I'm going to show you two problems that are not in your book. And these problems are pretty simple. But we are going over them so we know how it works. So this problem, like I said, is not in your book. 5 minus 3. That was something we learned back in probably elementary school. And we know what the answer is going to be, right? We're smart. That's not the purpose here. What am I starting with?
5.
I'm starting with a positive 5. Okay? I see a minus sign. So am I adding chips or taking away chips?
Taking away.
Taking away chips. What kind of chips do I need to take away? Positive chips. How many positive?
3.
3 positives, and I'm going to take away. How much am I left with?
2.
2. That's why it was elementary school stuff, because that was easy, right? But we had to see what the process looked like to apply it to some other problems. This is not in your book either, but it says 3 minus 5. Cole? What is my starting value?
3.
3. Starting with 3 positive chips, correct?
Yes, ma'am.
Yes, ma'am.
Adding chips or taking away?
Taking away.
Taking away. What kind of chips do I have to take away? Positive. How many positive? 5. Do I have 5 positives to take away? No. Here's where the problem lies, and I have to get creative. I know, actually, I'm going to start this over. I know, we started with what, 3? Started with 3. I've got to take away chips. If I put this up here, have I changed my workspace answer of a 3 that's up here? No. But how many positive chips do I have on my workspace now? 4 positive chips. I haven't changed my final answer, but I have more positive chips now. So, do I have enough to take away now? No. So I'm going to do another 0 pair. Have I changed this answer of a 3?
No, ma'am.
No. Do I have enough positive chips to take away? So I'm going to now take those positive chips. 1, 2, 3, 4, 5. Took away 5 positive. What is left?
2 negative.
2 negative. So what is 3 minus 5? Negative 2. So let's recap my steps. What did I start with? I started with 3. And then, what did we have to do?
Subtract by negative 5.
Yeah, but I couldn't. So what did I have to do next?
Add 2 0 pairs.
Add 2 0 pairs. Then what did I do? Subtracted 5 positive. Now let's look at some of your problems that's in your book. Negative 3 minus a negative 2. What am I starting with? Negative 3. Some people said you're supposed to start with negative 2 because it's in parentheses and that's what order of operations says to do. Truly, what order of operations says to do is work the problem in parentheses first. Do you see a math problem in this parentheses? No. There is just a number in that parentheses. The reason they have a number in that parentheses is because they don't want the minus and the negative signs sitting next to each other and confusing you as one line. So they properly write it as a parenthesis, so they're not confusing you. So it is not order of operations. You always apply order of operations, but there's no problem in this parenthesis. So what number is listed first in this problem? That is my starting value, -3. So I'm starting with -3 chips. Then I see a subtraction sign. My adding chips are taken away. Taking away. What kind of chips do I need to take away? Negative. How many negative? 2. So I'm taking away. Obviously, I had 2 negative chips to take away, right? So what am I left with? -1. Let's recap my actions I took. I had 3 negative chips on my workspace. What did I do next?
Took away 2.
I removed 2 what? Negative chips or tiles. So I didn't do anything else after that, right? So I know -3 minus a -2 is what? -1. Let's look at another. Number 8. We'll go back to, who knew this answer off the top of your head, honestly? I am greatly impressed. Number 8 says 5 minus a -1. What am I starting with? 5. Positive. 1, 2, 3, 4, 5. Adding chips or taking away? Taking away. What kind of chips do I need to take away? How many? What type of chips?
Negative.
I need to take away a negative chip. How many negative chips? 1. Do I have a negative chip to take away? So I have to get creative. So what do I need to do? Add a 0 pair. How many 0 pairs would make this helpful? 1. Okay, now do I have a -1 chip to take away?
Yes.
Does this currently still say a +5?
Yes.
Yes, that's what I wanted it to say. But once I remove this -1 and take it away, now what does it say? +6. Starting over, what was my starting value?
5.
5. I started with 5 positives. Okay? I have to take away chips, and I asked what kind of chips do I take away? A negative. How many negatives?
1.
Do I have any negative chips laying out here? No, so I have to get creative. So I'm going to write a 0 pair. Now do I have a negative chip to take away? Yes. Right now it says 5. When I take this negative chip away, now how many positive chips do I have? 6.
Why would you not just put the negative by the?
Then I changed that number to a 6, and that says 5. You can't change the problem. You have to just be tricky about it. So let's recap the actions that I took. I first had 5 positive tiles. Now what? Then what did I do?
Added a 0 pair.
Added how many 0 pairs? 1 0 pair. Then what did I do after I had the 0 pair? Removed 1 negative. There's a whole lot of moving back there. So 5 minus a negative 1 means is what? 6. Okay, let's look at another problem. 9 says negative 5 minus a negative 8. What is my starting point? Negative 5. 1, 2, 3, 4, 5. Adding chips or taking away? What tells you taking away? The subtraction. What kind of chips do I need to take away?
-8.
Negative chips. How many negative chips?
8.
Do I have 8 negative chips to take away?
No.
So I have to get creative and keep the same answer of a negative 5 here. So how many 0 pairs should I add?
3.
And what told you 3?
8 plus 5 equals 3.
Okay? Have I changed this answer from a negative 5 right now? It still says negative 5 because essentially these 0 pairs are 0. Now do I have enough negative chips to take away like they wanted me to do? Okay? How many do I have to take away? 8. So I'm going to circle my 8 negative chips to take away. What am I left with? My ending value? 3 positive. So, negative 5 plus a negative 8 equals what?
3.
3. Let's recap the actions that I took. Started with a negative 5. What did I do after that? Add 3 0 pairs. Then what did I do?
Subtract 8
I removed 8 negatives. Then I was just left with a positive 3. Some of you aren't writing your action steps, and you might wish you had. What?
Why is it the first one we did -3 minus parentheses -2 equals -1?
We already explained that with the chips. We'll go back to that later.
Oh, I see it.
Okay, looking at, I want to go to number 11 for time purposes. So flip to 11. Negative 4 minus 8. What am I starting with?
Negative 4.
Negative 4. So how many chips do I need on my board?
4.
4 negative chips. Okay, adding chips or taking away? And the subtraction told you that. What type of chips am I taking away? Positive. How many positives do I need to take away?
8.
Do I have positive chips to even take away?
No.
No. So I need to add some 0 pairs. So I'm going to add, do I have enough positives to take away 8?
No.
How many of these 0 pairs do I need to add?
8.
Some people tell me 4 all day long. Do I have 8 positive chips to take away?
No.
I only see 4 positive chips. So I need to keep adding some 0 pairs. Now do I have 8 positive chips to take away?
Yes.
Hey, where'd that calculator come from? You put it on my desk. They're supposed to all be put up. Non-calculator section. Now do I have 8 chips to take away?
Yes.
Yes. So I'm going 8 positives get taken away. What is left?
12, negative 12.
Negative.
Negative 12.
Oh my God.
Okay. What actions were taken?
Added 8 0 pairs.
Added 8 0 pairs.
Removed
Then what?
Removed 8 positives.
Remove 8 positive tiles. So what is negative 4 minus 8?
Negative 12.
Negative 12. Okay? These integer pieces is one way we can look at solving problems. Tomorrow we're going to look at number lines. Some people see it better with integer pieces, some people with number lines, and some people just sees it no matter what. And there's no workbook homework, there's online homework. Thanks for listening. Have a great day. Like, subscribe, hit the notification bell, and peace out, home dogs.